So yeah, robots can dance, they can walk around, they can interact. I think we're headed to a radically different world.
Your companion, it can be at your house, it can sort of babysit your kids, it could teach them, be a teacher.
Elon Musk has just unveiled Tesla Optimus Gen 3, an astonishing humanoid robot that's not only intelligent, but a blazing fast self-learning machine. Picture this, a robot mastering 1,000 new skills every single day, using nothing but Wi-Fi and YouTube. With its sleek design, powerful AI, and a price tag under $20,000, it's poised to revolutionize elder care by offering not just support, but real independence. The Tesla bot is no longer a concept. It's a rapidly evolving, cost-effective reality that may soon redefine how we live, work, and age. The future? It's already here, staring us in the face. But the real question is, are we truly ready to live alongside a machine that might someday outlearn us all? Or are you panicking, worried these robots will steal human jobs? Take a breath, because in today's episode of Tesla Car World, we're breaking down all the thoughts racing through your mind. Mention the words humanoid robot, and you'll likely trigger a wave of mixed reactions. For some, it sparks visions of a sleek, tech-driven future where machines handle everything from dangerous jobs to the tedious chores we love to hate: cooking, cleaning, maybe even folding laundry. It's the ultimate convenience fantasy, but not everyone's excited. In fact, a lot of people are uneasy, worried that these robots will edge humans out of the workforce, or worse, spiral into some dystopian scenario right out of a sci-fi thriller. Then there's the camp that just can't take these machines seriously. To them, most humanoid robots still seem clumsy, overpriced, and stuck in the uncanny valley, like someone tried to build a human out of spare parts and forgot to update the software. Comparisons to politicians or tipsy pedestrians aren't uncommon, and honestly, they're not entirely off base. Let's be clear, we're not saying Tesla has the most advanced robot on Earth. But when it comes to practical potential, robots that might actually help regular people live better lives, Optimus is leading the pack. It's not just powerful, it's within reach for more people than ever before, thanks to a price tag that makes home robotics a real conversation, not just a dream.
Well, I think the cost is actually not going to be crazy high, like less than a car.
Fundamentally, at scale, the Optimus robot, you should be able to buy an Optimus robot for, I think, probably $20,000 to $30,000 long term.
Elon Musk aims to make life easier for older adults who are struggling with the rising costs and inefficiencies of traditional caregiving. With an expected price tag of under $20,000, the Tesla bot isn't just an affordable option. It's a reliable companion that helps seniors stay safe and independent in their daily lives. So why can Tesla Bot Gen 3 learn over 1,000 skills per day?
Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing. Then you really have task extensibility that is dramatic, because then it can learn anything very quickly.
Recently, Tesla released a new demo video showcasing the impressive capabilities of Optimus as it performed a variety of new tasks, further reinforcing its potential as a valuable household assistant. The video sparked excitement and anticipation for the official launch of Optimus. In this latest showcase, Optimus completed common domestic chores like sweeping, vacuuming, and cooking simple meals. It used a microwave, picked up trash, and even cleaned with precision. The demo didn't stop at home life. The robot also handled industrial tasks like picking up automotive parts in a factory setting, signaling its ability to serve both households and production lines. What's most striking about Optimus's behavior is its simplicity. Rather than relying on a long series of coded commands, Optimus only needs a single voice instruction, such as pick up the broom and sweep the floor, to understand the task and complete it from beginning to end. It doesn't need a script. Just tell it what to do in plain language, and it takes care of the rest. Another standout capability is its two-handed coordination, a feature that marks a major leap from its earlier versions. Past iterations of Optimus mostly used one hand for basic tasks. Now it can fluidly use both hands in sync, allowing for far more complex human-like actions. Behind the scenes, its neural network is calculating real-time motion, paths, avoiding collisions, and maintaining balance. Optimus's dexterity is supported by Tesla's custom hardware. Each hand has 22 degrees of freedom, allowing for nuanced manipulation of tools and objects. This gives it a huge advantage over other robots, whose mechanical limbs are often too rigid or simplistic to perform useful real-world tasks. But Tesla isn't just innovating in robotics hardware, it's revolutionizing how robots learn. Most robots are trained using motion capture or remote control methods. Tesla is taking a more scalable and intelligent approach, letting Optimus learn by watching videos of humans. If this sounds a bit like how people use YouTube tutorials to learn how to fix a sink or cook a dish, that's the idea. Optimus can watch a video of someone stirring a pot, folding laundry, or cooking a steak, then recreate those motions in a virtual environment, practicing them billions of times in simulation. When it reaches near-perfect execution, it's deployed to the real world. This form of self-learning through simulation allows Optimus to acquire new tasks much faster and more efficiently than with traditional methods, and it gets even more impressive. Tesla has created a centralized intelligence system. This means that when one Optimus learns a task, say, making an omelet, that knowledge is instantly available to every other Optimus robot on the planet. There's no need to retrain each robot individually. The system is modeled after Tesla's success with autonomous driving AI, which has collected insights from billions of miles of road data to improve vehicle decision-making. As Elon Musk explained,
It's got the real-world AI. So Tesla's the leader in real-world AI. What we learned in the car, we translate to the Optimus robot. And we also take our expertise in electric motors, in batteries, power electronics, structural design. And then another major important thing is that we're very good at manufacturing.
this manufacturing advantage is what makes Optimus different. While most robots are built in limited numbers for research labs or exhibitions, Tesla is preparing Optimus for mass production. That changes everything. As the number of deployed units grows, so does the collective intelligence of the entire Optimus network. In industrial settings, this centralized system creates massive efficiency. If one Optimus robot learns how to assemble a component for Tesla's Cybercab robotaxi, that process is shared instantly across the factory floor. With potentially thousands of robots learning and sharing simultaneously, Tesla could build a library of millions of distinct tasks in just a year. In homes, that same intelligence makes Optimus a powerful personal assistant. From vacuuming and wiping surfaces to drawing curtains and serving drinks, Optimus can become an all-in-one helper, adapting to the needs of individual users and learning new tasks on the fly. Some might question whether Optimus is learning real skills or just mimicking motion. But Tesla's learning model is based on error correction at scale, something even human experts can't replicate. While 1,000 chefs might learn how to cook a steak with varying results, one Optimus can perfect the technique in simulation, then distribute that perfect method to every other unit. This level of accuracy and consistency could make Optimus indispensable, not just as a cleaner or cook, but eventually in fields like elderly care, logistics, or healthcare, where precision and safety are paramount. Musk has called Optimus potentially the biggest product of all the time for Tesla, even bigger than electric vehicles. Given its adaptability, collaborative intelligence, and manufacturing readiness, that prediction doesn't seem far-fetched. We're witnessing the early stages of a robotics revolution that could transform how we live and work. For now, Optimus Gen 3 is still evolving. It's not yet flipping pancakes with style or babysitting toddlers, but its core strengths are already clear. It learns fast, shares knowledge instantly, performs tasks reliably, and improves continuously. Whether in a home, a warehouse, or a factory floor, Optimus is poised to be more than just a robot. It's the future of intelligent, scalable assistance. And with Tesla leading the way in real-world AI, manufacturing, and robotics, that future may arrive sooner than we think. So, how long can a Tesla bot Optimus be used? Tesla's Optimus Gen 3 isn't just a leap in robotics, it's a commitment to long-term performance and sustainability. While many commercial robots are designed to last between 5 and 10 years, Tesla is setting a far more ambitious standard. Optimus is built to operate reliably for up to 24 years under real-world conditions, without the need for major overhauls. This impressive lifespan isn't just a marketing claim. It's the result of meticulous engineering across every component: structural, mechanical, electronic, and digital. From aerospace-grade materials to advanced AI and battery systems, Optimus reflects Elon Musk's goal of creating a robot that not only works, but keeps working for decades. Let's start with the robot's physical core. Optimus's skeleton is made from 7075-T6 aluminum alloy, a material prized in aviation and aerospace for its exceptional strength-to-weight ratio. With tensile strength around 83,000 pounds per square inch, this alloy ensures the frame can withstand daily physical stress over decades of movement, lifting, and fine motor activities. For the robot's most vulnerable joints, such as the shoulders, knees, and spine, Tesla uses carbon fiber reinforced polymer, CFRP. It's lightweight, strong, and impact-resistant, helping the robot maintain agility while withstanding sudden impacts. Unlike heavier metals like titanium, used in some rival robots, CFRP allows Optimus to stay nimble and power-efficient over a long lifespan. Internal mechanics are equally future-proofed. All joints and moving parts are built for high cycle endurance. Tesla stress tests each major joint with 1.5 million full flex cycles, simulating more than 20 years of typical use in environments like homes, warehouses, and manufacturing floors. The gearboxes run on high-grade synthetic lubricants and stainless steel bearings, while the motors feature thermal shielding and intelligent load balancing to prevent overheating. The energy system is another critical part of this 24-year goal. Optimus is powered by Tesla's in-house 4680 battery cells, optimized for long lifespan and stable output. These cells have shown in lab simulations the ability to retain over 80% capacity after 3,500 full charge cycles. Assuming Optimus works 6 days a week with one full charge per day, that's more than 20 years of operation, and potentially 24 years with intelligent power management and partial cycle optimization. Tesla's battery management software adds another layer of durability. It features adaptive charging algorithms that regulate temperature and prevent long-term chemical wear. By limiting high-stress conditions like full discharges and overcharging, the system can stretch the battery's practical life beyond typical industry expectations. But raw power and materials aren't enough. What sets Optimus apart is its intelligent self-preservation. The robot's neural network, adapted from Tesla's full self-driving AI, allows it to detect wear or irregular force in any limb and make real-time adjustments. If a joint starts experiencing abnormal torque, Optimus can reduce its load and redistribute effort to other joints, protecting its own hardware from long-term degradation. This smart behavior extends to thermal and motion control, helping Optimus remain cool and balanced, even during long workdays. The robot also includes modular architecture, allowing users to replace individual parts, motors, sensors, actuators, without needing to dismantle the entire system. This not only saves on maintenance costs, but extends the overall life of the unit by making minor repairs instead of full replacements. To ensure it holds up over the decades, Tesla puts Optimus through extreme stress testing. Temperature swings from -25 degrees Celsius to 50 degrees Celsius, drop tests, vibration tests, and dust chamber simulations. The company also runs digital twins of the robot through tens of thousands of simulated operating hours, identifying potential weak points well before production. Even sensor arrays, such as vision cameras, torque sensors, and gyros, feature redundancies, ensuring the robot remains functional even if a module fails. This keeps Optimus active without costly downtime, adding years of usable life across its deployment cycle. Looking at Tesla's track record, this kind of long-term durability isn't new. Many early Tesla Roadsters released over 15 years ago are still on the road, running on their original drive units and batteries. The same dedication to hardware and software resilience is now being translated into robotics. When you combine Optimus's structural strength, intelligent learning, self-regulation, and shared AI system, the result is more than just a useful machine. It's a reliable coworker that improves over time and remains valuable for 2 full decades and beyond. So, in under 2 years, how Tesla just made every other humanoid robot obsolete. Most humanoid robots today exist more as lab experiments than functional tools. We've seen countless flashy videos, robots performing backflips, dancing, or doing menial tasks, but most disappear without making it to market. The reality is they're not built for scale, nor are they designed to integrate into everyday life. Many are simply high-tech prototypes that never leave the lab. In a bold move that flipped expectations, Tesla brought 50 fully functional Optimus Gen 3 bots to a major live event, originally planned to showcase their Cybercab autonomous taxi. But instead of all eyes on the vehicle, it was the Optimus robots that stole the spotlight. Attendees gathered around them, interacted with them, and for many, this marked the first time a humanoid robot actually felt real, reliable, approachable, and practical. This advanced humanoid robot can inspect and receive deliveries, serve drinks, fold laundry, and clean the kitchen with ease. At a target retail price of $20,000, Tesla is aiming for mass adoption. Thanks to in-house manufacturing and shared parts with Tesla vehicles, especially the 4680 battery, production costs are estimated around $10,000 per unit. This allows Tesla to sell at a price point no other company in the space can currently touch. At that price, Optimus becomes accessible to households, small businesses, and institutions, moving the humanoid robot from fantasy to functional reality. And if you're still wondering whether this is just another overhyped product, remember, Tesla has a track record. From electric vehicles to solar to battery storage, they've proven time and again they can scale complex technologies. Optimus is simply the next step in a larger ecosystem of AI, autonomy, and energy. Would you be willing to spend $20,000 on a robot like Optimus? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. Bots like Tesla Bot Optimus advance, countless workers will lose their stable incomes. It's true, when ATMs appeared, many bank tellers at the counter were let go as cash deposits and withdrawals became fully automated. So, it's inevitable that a versatile humanoid robot like Optimus will gradually take over certain tasks. Yet by ATMs actually laid the groundwork for banks to open more branches to capture market share and multiplied teller headcounts many times over. That's why having one or even several Tesla bots handling chores like mopping floors, cleaning windows, vacuuming, doing dishes, or even cooking, with up to 10 hours of independent operation on a single charge, is necessary. As Elon Musk himself has confirmed this milestone.
In 2026, it's really the kind of thing where you could tell it to do a wide range of tasks.
Believe us, the Tesla bot is a machine whose true value far exceeds its price tag. So what exactly can the Tesla bot do? And why should we trust this walking robot with our homes? Welcome to Tesla Car World. Most users' concerns about robots are valid. Fears of production downtime, hidden costs from charging wait times, and the drive to maximize productivity have all undermined confidence. So how can the Tesla Bot Gen 3 run longer than a standard work shift? According to internal Tesla documents, Optimus Gen 3 ships with a 2.3 kilowatt-hour battery, drawing roughly 100 watt on standby and up to 500 watt during high-intensity tasks like rapid locomotion or lifting heavy objects. Tesla hasn't disclosed the exact physical dimensions of the Gen 3 pack, but has confirmed that Optimus uses the 4680 cell, the company's most advanced battery technology to date. For example, if Optimus Gen 3 uses a 4680 battery pack with a 2.5 kilowatt-hour capacity, it could run for at least 10 hours before needing a recharge. The robot's battery differs from those in electric cars. It draws less power because most of its tasks are performed in place, with only some requiring continuous movement. Of course, we also expect that if Optimus is frequently on the move and carrying heavy loads, its battery life will drain more quickly than normal. And it doesn't stop at the built-in battery. Tesla is developing a hot swap battery module for Optimus Gen 3 to enable around-the-clock operation. In that scenario, a depleted module can be swapped out for a fully charged one in just minutes, allowing the robot to resume work without downtime. That capability would ensure zero interruptions in continuous production assembly lines, overnight warehouse logistics, and critical rescue or emergency medical service applications.
You can imagine like your own personal robot buddy that is a great friend, but also takes care of your house. We'll clean your house, we'll mow the lawn, we'll walk the dog, we'll teach your kids, we'll babysit, and will also enable the production of goods and services.
But how is that even possible? Elon Musk has repeatedly mentioned that Tesla's humanoid robot can perform thousands of tasks. It's already surpassed 1,000. With each future update, it could handle 5,000 or even 10,000 different tasks. For example, at first it could only cook 10 recipes. With each update, it could add 50 more dishes to its repertoire, and eventually it will be able to cook anything, as long as you provide the necessary ingredients. Why can it recharge in just 10 minutes? Most recently, a new update revealed exactly how Optimus recharges, and it really surprised us. Until now, we all assumed charging Optimus would be just like charging an electric car. You bring it to a charging station and plug it in. In reality, it's quite different. Optimus can recharge itself without any user plugging in, meaning the entire process is fully automated, much like the self-driving features of the Cybertruck. It's hard to believe that the Tesla Optimus can charge itself without manual intervention. As shown in the video, Optimus autonomously locates, navigates to, and connects with a wall-mounted charger that has an extendable connector. Once its battery is fully charged, it automatically disconnects and resumes its tasks. Because Optimus uses wireless charging with a battery pack of just under 3 kilowatt-hours, it can recharge far faster than electric vehicles, which typically need 30 to 40 minutes for a full charge. We believe 10 minutes will be enough to fully recharge Optimus. In 2022, Tesla first introduced Optimus with a 2.3 kilowatt-hour battery, but at the time, the prototype mainly used standard 2170 battery cells, as the 4680 battery technology was not yet available. As a result, Optimus had a rather bulky and rudimentary design. However, Tesla has since confirmed that Optimus has been integrated with the company's most advanced 4680 battery technology, although detailed specifications have not been disclosed. The 4680 battery offers many significant advantages. With a higher energy density that's 5 times greater than the 2170 cells, it provides more energy per unit volume while reducing production costs by approximately 14%, thanks to improvements in design and manufacturing processes. These benefits have made a major leap in optimizing energy and efficiency. When integrating the 4680 battery into the Tesla bot, Optimus's design became more compact, eliminating the need for a large and bulky battery pack. This not only improved performance but also significantly reduced the robot's weight. For example, the second-generation Optimus shed 22 pounds, dropping from 160 pounds in the first generation to 138 pounds. Thanks to the superior energy density of the 4680 battery, it not only reduces the size of the battery pack, but also provides enough power for Optimus to operate continuously for 8 to 10 hours. Compared to the first-generation version with a 2.3 kilowatt-hour battery, the second-generation Optimus uses a slightly larger 4680 battery pack, reaching up to 3 kilowatt-hour. What's truly surprising is the recent update about how Optimus charges. Until now, we've all assumed that charging Optimus is like charging an electric vehicle. You have to plug it in manually, but it turns out it's far smarter than we thought. With Optimus, as shown in the video, it can autonomously locate, navigate, and connect to a wall-mounted charger with an extended connector. This is a charging port that Optimus aligns and connects to by itself. Once the battery is fully charged, it automatically disconnects and resumes its tasks. If Optimus is charged using wireless charging, it will charge much faster compared to electric vehicles, which typically take 30 to 40 minutes to fully charge. We believe 10 minutes would be enough to fully recharge Optimus. Elon Musk has emphasized many times that the Tesla bot is actually a machine worth much more than the money that customers spend to own it. One of its standout abilities is learning through video, allowing the robot to absorb and replicate complex behaviors from visual motion data. This capability not only helps Optimus perform tasks on Earth, but also plays a key role in Elon Musk's broader plan to deploy the robot on Mars. Video learning is an advanced AI technique in which a robot or AI system analyzes video footage to recognize patterns in behavior, movement, and context. For Optimus, videos serve as a rich source of data, offering a continuous and visual representation of the physical world. For example, by watching a video of someone assembling a device or performing a manual task, Optimus can analyze each step, from gripping tools to coordinating movements, and then accurately reproduce the same actions. Optimus doesn't need hand-holding. Just show it a video, whether it's a cooking tutorial, machinery repair, or a cleaning task, and it can analyze, learn, and replicate the actions almost instantly. Unlike humans, who might take weeks to master a new skill, Optimus only needs a few minutes. Take cooking a steak, for instance. Optimus watches a chef's video, practices virtually millions of times, and self-corrects errors until it achieves 99% accuracy. Then, it's ready to step into a real kitchen. What's more, Optimus can also learn directly from humans. You can teach it to fold a shirt just by demonstrating once, and if it makes a mistake, a simple correction like, "No, fold this corner first," is enough. Optimus will remember and improve. A breakthrough feature of Optimus is its collaborative learning system. When one Optimus learns a new skill, like a dance routine, it uploads that knowledge to the network, and every other Optimus instantly acquires it. Imagine a team of robots dancing in perfect sync, like professional performers, without ever having trained together. With 1,000 robots, each learning one task per day, the Optimus skill set would grow by 1,000 tasks daily, an almost unimaginable learning speeds. Since unveiling Optimus, Elon Musk has mentioned plans to send the robot to Mars at least 3 times. The most recent mention was in March when Musk posted on X, "Starship departs for Mars at the end of next year, carrying Optimus." If those landings go well, then human landings may start as soon as 2029, although 2031 is more likely. Of course, the exact timeline is still up for debate. After all, Starship's success has yet to be fully proven. But setting schedules aside, the role of Optimus in the mission to colonize Mars is hard to overstate. Optimus isn't like traditional rovers such as Curiosity or Perseverance. It doesn't rely on GPS, which doesn't exist on Mars, but instead uses a 2D camera system for navigation. On a planet filled with dust, rocks, and unpredictable terrain, the ability to adapt and analyze surroundings in real time is a major advantage. Recent tests show that Optimus can climb stairs and walk across uneven surfaces, not quickly, but steadily. This opens up the possibility for a new generation of robots capable of exploring canyons, hills, and even caves, places that traditional wheeled rovers simply can't reach. But what truly sets Optimus apart isn't just its flexible body, it's the artificial brain behind it. Optimus has the ability to learn from its environment, analyze minerals, and identify vital resources like frozen water, an essential factor for any long-term settlement effort. Imagine an Optimus autonomously transporting supplies, building power stations, or deploying environmental sensors in areas no human has ever explored, all without direct input from Earth. The real question is, how will Tesla recharge Optimus on Mars? If Elon Musk can solve that challenge, Optimus's potential is undeniable. What kinds of tasks can the Tesla bot Optimus Gen 3 perform during its work shift? Tesla's newest clips reveal Optimus seamlessly handling a host of everyday duties. It gently waters houseplants, retrieves deliveries from the porch, scrubs kitchen counters until they gleam, and effortlessly hauls groceries from the vehicle into the pantry. Rather than a mere gadget, Tesla positions Optimus as a genuine household partner, one that can watch over children or offer companionship to older adults. Already, Optimus carries on fluid, natural-sounding conversations, entertaining curious youngsters and providing comforting dialogue for seniors, making it clear that this robot is built to fit smoothly into daily life, not sit dormant in a corner. Of course, observers worry about hygiene. If Optimus empties trash and then prepares lunch, can it cleanse its mechanical hands as thoroughly as we do? While we're not the engineers behind Tesla Bot, we do know that Optimus's grippers are among the most sophisticated ever built. Tesla's tendon-driven design mirrors human anatomy while minimizing delicate joints that could jam or corrode when wet. The materials chosen resist soap and water, and may even have antimicrobial properties. So, it seems Tesla has anticipated cleanliness from the start. Given that half of the development effort focuses on its hands, we're confident a rigorous sanitation process is in place. Imagine unboxing Optimus only to spend weeks programming every motion yourself. What a chore. Thankfully, this robot learns by watching. Instead of feeding it massive labeled datasets, you simply show Optimus a short video demonstration, and its onboard neural nets generalize the steps needed to replicate any task. Perhaps most impressive is Optimus's fluency in body language. Point toward a coffee mug, and the robot instantly grasps your needs. Wave at a toy on the floor, and it stoops to pick it up. This gesture-based interface makes it accessible for anyone, including those who struggle with speech. These breakthroughs stem from Tesla's in-house AI brain, now powered by the company's Dojo D1X supercomputer rather than third-party chips. By repurposing the same neural networks that enable autopilot, Tesla has leapfrogged rival efforts to build a practical two-legged assistant. Early adopters can reserve Optimus today, with pilot deliveries slated for mid-2026 at a starting price of $35,000. As production ramps up and costs fall, Musk expects the price to dip below $20,000 within 2 years, making this once fantastical helper an affordable fixture in homes everywhere. But the question is, when will the Tesla bot actually be able to pull off these tasks? Our answer, not long from now. Everything could become reality in 2026. Elon Musk himself has confirmed that timeline. Tesla will have genuinely useful humanoid robots in low production for Tesla, internal use next year, and hopefully high production for other companies in 2026, Musk said. That makes perfect sense, since it lines up with Tesla's roadmap for its humanoid robot. This year, Tesla is focused on refining and upgrading Optimus, building a limited number of units for events, demos, and testing. The Gen 3 prototype is slated to debut in December. At first, many assumed that Optimus would be built solely for Tesla's auto manufacturing plants, with no plans for civilian applications. Yet Elon Musk took to X to announce that beginning in 2025, Tesla will roll out a limited run of humanoid robots for internal use. He said, "My projection is that next year we'll have over 1,000, maybe a few thousand Optimus robots working at Tesla. It's almost certain that the future of manufacturing will be dominated by robots. Lots of them. Automation is the only viable path to a sustainable future, and Musk has long championed the concept of machines that build machines. Tesla's gigafactories already feature extensive automation, from massive robotic arms and gigapresses to stamping lines and paint booths. But these machines are fixed in place, and each handles just one task. True end-to-end automation demands flexible mobile robots, and that's precisely what Musk is developing. Tesla isn't keeping this under wraps, they're showcasing it openly. In the latest Optimus demo video, the robot navigates an automated workspace teeming with machines and human workers. Its ability to find its way in unfamiliar terrain is striking. Think about entering a new building. You pause, decide which hall to take, maybe even get lost. In a sprawling facility like Giga Texas, you'd normally need a map or directions. Optimus doesn't. It autonomously maps its surroundings, recognizes equipment, people, and zones, and uses that data to chart its course. That's how it functions inside Tesla's factories. Right now, manufacturing faces a shortfall of about 300,000 workers, and warehousing and logistics are short roughly 600,000 to 700,000 roles. Would you be comfortable having an intelligent robot like Optimus handle household chores, from mopping floors and cooking to childcare? And what concerns do you have about entrusting these tasks to a robot? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos.
The thing that'll make the biggest difference is being able to interact with the real world via humanoid robots. So you combine Grok with Optimus and it can actually interact with the real world.
Slow, clunky, dumb, just expensive toys. That's how most people still see humanoid robots. Overhyped machines with over $50,000 price tags that do little more than wobble around like relics from a failed sci-fi dream. But that narrative ends now. Elon Musk and Tesla are integrating Grok 4 directly into the Tesla bot Optimus. Now imagine this, an AI as smart as ChatGPT-4, but with eyes, ears, arms, and legs. A robot that doesn't just talk, but sees, moves, understands, and acts. One that can mop your floors, fold your laundry, cook your meals, teach your kids, and gently lift an elderly person back on their feet. And the most important part? The final cost of a Tesla Optimus will still be affordable, just $20,000. So how useful is this latest Tesla bot integration in the real world? Welcome to Tesla Car World. How is the Tesla Bot Gen 3 equipped with Grok 4? During a recent Grok 4 reveal streamed on X, Elon Musk slipped in a noteworthy status report on Tesla Optimus. Elon Musk has pledged to graft xAI's brand new Grok 4 model directly into Optimus's neural core. Grok 4-Tesla's latest language-first AI boasts a 130,000 token context window and can chew through more than 1.8 million tokens every second, running native tools and coordinating multiple agents at once. Compared with the most advanced ChatGPT-4 today, GPT-4 tops out at 128,000 tokens, but averages roughly 55 tokens per second through the public API, a respectable figure for chat, yet tight once you add depth cameras, audio, and proprioception streams. Far from a routine software refresh, this model is intended to serve as the thinking cortex that propels Optimus beyond its current factory boundaries. Milliseconds count when a robot must snatch a dropped plate before it shatters. Infrastructure widens the gap. Musk says future Optimus units will run a compiled Grok variant on Tesla's FSD and, eventually, Dojo Silicon, keeping inference local and private. GPT-4 remains cloud-bound. Every command travels to an OpenAI server, so a Wi-Fi hiccup stalls the robot, and household data traverse third-party logs. Priced in the $20,000 to $30,000 bracket, Optimus is already spec'd for duties that are hazardous, repetitive, or simply mind-numbing for people. Yet, its true potential emerges when Grok 4 is wired in. Musk confirmed that work on the Fusion is active. The Gen 3 prototype already taps Grok for natural language dialogue and voice control.
Yeah, you'll be able to customize the personality, customize the voice, and really kind of the robot will kind of get to know you as well and know your preferences. You won't even have to say things because it'll just kind of understand you.
Grok 4 functions as a reasoning engine, letting the robot tackle jobs that mix language, mathematics, coding, and scientific deduction. Tasks that stump conventional robots locked into fixed command lists. Because Grok understands real-time data streams, Optimus can read its surroundings, juggle several chores simultaneously, and adjust its behavior on the fly. On a production line, that means spotting a bottleneck and recalibrating without human intervention, but the same skill set scales cleanly to everyday living spaces. Security also favors the homegrown model. Because Grok inference can run locally, video from nursery cameras or factory tooling never leaves the premises. A ChatGPT-driven unit would stream those frames to the cloud for captioning, a non-starter for many enterprise compliance teams and privacy-minded households. Regulators already flag cloud data flows under the General Data Protection Regulation and the California Privacy Rights Act. Tesla sidesteps that friction by keeping bits on its own silicon, cutting red tape on the path to large-scale deployment.
Like in 2026, it's really the kind of thing where you could tell it to do a wide range of tasks.
Most people agree that if Tesla's Optimus can handle basic chores like mopping the floor, it will already be worth every penny. The idea that a single machine might polish windows, vacuum carpets, and even wash dishes has long seemed like something that belonged only in the movies. Yet that fantasy is edging toward reality. Tesla Bot is here, able to tidy your home for up to 10 hours on a single charge, and Elon Musk keeps repeating that the value packed inside the robot far exceeds what customers will pay for it. Grok 4 will not just give the robot a chatty voice assistant, it will supply a reasoning engine able to break down vague instructions, ask clarifying questions, and improvise when the home environment shifts. The Fusion marries FSD's vision stack, which already teaches Optimus spatial awareness, to a 300+ billion parameter language brain explicitly tuned for real-world engineering puzzles. Musk's claim is blunt. The next chassis revision will ship with Grok baked in, turning every household robot into a conversant coworker rather than a programmable appliance. If that integration works as advertised, those 10 hours of battery life stop being an isolated spec and become a full shift. The machine can review a messy kitchen, schedule its own workflow, decide the windows need wiping before the clouds roll in, and still ask whether the dog should be walked before dinner. It reframes the unemployment fear too, because a Grok-enabled Optimus is less competitor than collaborator, absorbing drudgery while humans move upstream to tasks that trade on empathy, taste, or strategic judgment. Whether the labor market adjusts smoothly is another debate, but the prototype hints at a future where a robot's economic contribution is measured in household hours freed, not in jobs destroyed. Remember, though, that trust is earned through time on task. The first Model S drivers endured beta software and incomplete charging networks. Early Optimus owners will shoulder similar growing pains. Yet Tesla's velocity matters here. Every chore captured by in-house cameras feeds a self-supervised loop, letting thousands of robots learn collectively what a single one experiences locally. That dynamic feedback is something Boston Dynamics never truly enjoyed, and it explains why Musk invests so aggressively. Scaling data, not just hardware, is how you slash cost curves. So imagine, a few model years forward, a device that greets you at 7 a.m., notes that your toddler left cereal on the sofa, slides a note onto your smartwatch, reminding you of an afternoon meeting, then silently wheels the recycling to the curb while the house is empty. Because it speaks fluent Grok, It can negotiate with the smart thermostat to cut heating, ventilation, and air conditioning use in rooms nobody occupies, or fetch the part number for a cracked faucet it detected by sound. In the evening, it might read a bedtime story using the same cadence it learned from your own recordings. You do not program any of this. You merely converse with a machine that has eyes, limbs, and a brain stitched together from two of Musk's most audacious ventures. Critics will remain they should add. A talking automaton that handles cutlery raises questions of liability, privacy, and the dignity of human labor. But dismissing Optimus today is a riskier bet than mocking early electric cars in 2010. The roadmap says multiple surprises are queued before year-end, and Musk rarely overshoots the dramatic arc of his announcements. He has sunk billions into this biped because he believes it will be the most sophisticated, most coveted robot of its generation and eventually the cheapest cost per hour labor ever sold at retail. To be clear, GPT-4 is capable. Researchers have demonstrated it by composing action plans for simulated humanoids. Yet when the brief is 1 million physical units bending metal and folding t-shirts, the integrated stack wins. Grok 4 lives closer to the robot's hardware, speaks the same kinematic dialect, scales economically with production, and keeps secrets on board. For these reasons, Grok 4 looks like the obvious brain for Tesla's mass-market robot. When will this version be mass-produced in real-world applications? In mid-2025, xAI unveiled its most powerful AI engines yet, Grok 4 and Grok 4 Heavy, and confirmed that Tesla's Optimus Gen 3 robots will ship with Grok 4 baked in. With a new, top-tier Super Grok Heavy subscription at $300 per month, developers and power users gain early access to Grok 4 Heavy's multi-agent reasoning system, which runs multiple model instances in parallel to boost accuracy on complex tasks. Benchmarked against industry leaders, Grok 4 outperformed OpenAI's GPT-4 and Google's Gemini on humanity's last exam without tools, while Grok 4 Heavy hit 44.4% when tool-enabled, nearly double. Gemini 2.5 Pro's 26.9%. In April's demo, the Gen 3 prototype used Grok for natural language dialogue, real-time environment mapping, and dynamic task planning, mopping floors, folding laundry, even coaching exercise routines, all on a single charge. Available today via xAI's API and soon through expanded cloud hyperscaler partnerships, Grok 4 makes Tesla bot Optimus the first mass-market robot with a true thinking cortex. By autumn, Super Grok Heavy subscribers will also preview an AI coding model, a multimodal agent, and video generation tools. Firm evidence that in 2025, a fully Grok-powered Optimus is not just promised, but already in developers' hands. Convenience, an aging population, and a rising appetite for smart home tech are the principal accelerants. Tesla means to meet that appetite with the third generation of Optimus. The new model can work 10 straight hours before docking, gliding from vacuuming and mopping to drawing curtains and stowing dishes. A short demo video posted in April eclipsed 56 million views within days, and deposits from more than 5,000 buyers followed. Public curiosity is unmistakable, but turning clicks into delivered units requires more than slick choreography. Gen 3's advantage begins with cognition. Its control stack borrows heavily from Tesla's full self-driving neural network, yet instead of roadway footage, the training corpus consists of people performing household chores. The system spots patterns, labels micromotions, and, according to the engineering team, can assimilate roughly 100 new tasks every day. Such continuous learning should keep the platform useful long after the factory image ships. The hardware is tuned for dexterity rather than spectacle. 22 degrees of freedom in each arm, coupled with fingertip pressure sensors, enable Optimus to crack an egg without spilling yolk, tighten a jar lid, or balance a laundry basket. The chassis weighs 56 kilograms, about 30% lighter than Boston Dynamics Atlas, making it easier to slip through narrow hallways and cheaper to power. All of this sophistication would be academic if the sticker price matched Atlas's six-figure cost. Instead, Tesla targets an introductory range of $15,000 to $30,000 and believes volume manufacturing can drag that below $20,000 by 2026. At those numbers, a capable humanoid costs less than a used compact car, but could displace several paid hours of labor each week. Executives also hint at a subscription tier around $25 per operating hour, a robot-as-a-service option for households or small firms that prefer not to own outright. Manufacturing scale is where most ambitious robot startups falter, yet it is familiar territory for Tesla. A pilot line in Fremont has already assembled 9 Gen 3 units, and the roadmap calls for 5,000 to 12,000 machines next year, swelling to as many as 100,000 in 2026. The company can lean on existing supply chains for 4680 battery cells, camera modules, and custom silicon, shaving costs that would strangle a smaller rival. Evidence of practical viability is visible on Tesla's own factory floors, where hundreds of early Optimus prototypes now ferry parts, arrange battery packs, and sort bins around the clock. Gen 3 improves on those trailblazers with a 10-minute rapid charge cycle that keeps downtime negligible. For home use, voice control spans 15 languages and reaches roughly 95% recognition accuracy, allowing natural conversation with most U.S. households. Elon Musk frames these milestones inside a broader thesis. Labor, not capital, is the ultimate bottleneck. He speaks of infinite demand for safe, affordable humanoids and values the long-term market at $10 trillion. Even if that figure proves optimistic, Optimus still represents a commercial horizon larger than the global car business. An aging population, shrinking leisure time, and a tight service sector job market create structural pull. If the robot can deliver reliable work for single-digit dollars an hour, orders could outstrip even Tesla's aggressive forecasts. Humanoid robots have dazzled conference halls for decades, only to fade when real-world complexity intrudes. Tesla, though, brings 2 assets predecessors lacked: mass production muscle and a vertically integrated AI stack. Dojo supercomputers digest petabytes of video, the FSD vision code transfers wholesale, and in-house chip design ensures Optimus will not be hostage to third-party silicon shortages. Those synergies could prove decisive where past efforts stalled. For the average American family, juggling commutes and caregiving, reclaiming 90 minutes of evening downtime is compelling. Imagine coming home to polished floors, chopped vegetables, and lunchboxes packed for the next morning, all completed quietly while you answered emails. Spread that across months and a $10,000 outlay starts to resemble a premium laptop amortized over its useful life. Small retailers might schedule units overnight for inventory counts and cleaning, paying only for productive minutes and freeing human staff for customer-facing roles. Mainstream adoption will still take time. Early owners must validate safety, durability, and service logistics just as the first Model S drivers once beta-tested over-the-air updates. Yet momentum is undeniable. Consumer demand is rising. The intelligence layer grows more capable with every frame of training data, and Tesla's manufacturing engine is already humming. Should the cost target hold, Gen 3 could enter households as inexorably as dishwashers and microwave ovens did in previous generations. Competitors will not stand still. iRobot, now backed by Amazon, is experimenting with articulated arms that may soon graduate from countertop demos to production Roombas capable of picking up clutter. Samsung and LG are fusing humanoid torsos with smart home ecosystems, banking on appliance channels and brand loyalty. Yet none control an end-to-end AI pipeline on Tesla's scale, nor do they operate battery gigafactories that can subsidize hardware margins. Besides, humanoid designs straddle categories in U.S. safety codes, which were written for fixed industrial arms or mobile gadgets. Tesla is lobbying for a certification path akin to the automotive crash test program, voluntary but influential, that would score pinch force, fall dynamics, and data privacy. If adopted, such a standard could grant insurers and homeowners a common yardstick and accelerate the entire sector. Finally, Will families tolerate a two-legged machine in intimate spaces? Early pilot studies hint that trust grows when the robot demonstrates competence, yields the right-of-way to toddlers, and asks permission before discarding objects. Tesla's user experience team is training Optimus to modulate posture and eye line so that the machine feels helpful rather than intrusive, a subtle but essential detail once the novelty wears off. Do you think a $20,000 to $30,000 price tag for a Grok 4-powered Optimus robot is worth it, given its promise to handle chores like cleaning, cooking, and elder care? Why or why not? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.